Hi everyone, bonjour. The IB Crocodile is here. Welcome to my YouTube channel. Let's have a look at this question here. Past papers, physics, high level, paper 1, November 2022, number 28. So a telescope can just resolve images that are separated by an angle of 2 times 10 to the power of negative 7 radians. Two stars are a distance of 4 times 10 to the power of 16 meters from each other. What is the maximum distance between the stars and the telescope for their images to be resolved by the telescope? So this question here is about resolution or resolvance. So let's have like a quick revision about this concept here, topic 9, or basically 9.4. But before I proceed, I want just to mention that resolution and thin film interference are removed from the new program, are removed from the old program. So now if you are fresh student starting 2023 physics IB, don't worry about this question. Resolution and thin film interference are removed. But of course, if you are senior student, like this is your DP2, right, and you are going to have an external assessment in 2024, so still you are following the old curriculum, which is that's why I'm doing this video today. So this is for DP2 students, high level. Still you need to finish this year, and then from 2025 we will have the new first external assessment for the new curriculum. So what is resolution or what is resolvance? So resolvance of an object means being able to see it as separate to its surrounding. So when you look at this picture here, you know, this picture is blurry, right? You can see, okay, there are some, like there's couple here in the picture. There is some grass here, but you cannot really see the grass as separate or more details about the people in the picture, right? So that's why we call this is a low resolution picture, right? So there in physics, you know, there is something called Rayleigh criterion for resolution, and this is what the question about. So what is the idea here? So let us have, okay, let's now assume that we are light is diffracting through a circular aperture or slit. So now this circular aperture is basically the telescope, or it could be the pupil's eye or whatever. And then, you know, each object will have its own profile. We call it single slit diffraction. So I have, for example, here a single slit diffraction from a certain object and another single slit diffraction profile. This is the intensity. So this is, like, for example, here, or relative intensity. So in single slit, you know, we see there is a central maximum, right? And then, you know, the brightness or the intensity will go down further from the center, right? So this here, this point here, this is called the central maximum or the principal maximum of the single slit diffraction. Now, Rayleigh criterion states that, okay, for a two stars or the two objects, you know, to be resolved or to be seen as separate from its surroundings, states that the condition here is the first or the principal maximum cannot be closer to the first minimum of the second object, which means, okay, they coincide on each other here. Okay, and in this case, for example, okay, this is just being resolved, right? Now this is, okay, this is even further. So this is resolved, but this is unresolved because here, you know, the first maximum is even closer than the first minimum of the second object. Okay, so then there is a couple of formula here. Theta, which is the angular separation between the two lines or the line of sight, you know, for the stars or whatever in this question here, the stars, right? So theta is the angular separation, has to be at least equal 1.22 times lambda over b, where lambda is the wavelength of the light and b is the diameter of the aperture or the slit. The proof of this formula is not required in the IB diploma, so you just need to know this formula here. However, this formula will not be used, will not be helpful in the question, because the question did not mention anything about lambda or even the diameter of the slit or the radius of the slit, right? So in this case, we are going to use the other formula here, which basically trigonometry. So the theta or tan theta, because it's a very small angle here, so we can use the tan theta approximation. So we can say theta is equal approximately tan theta is very, very close number, right? And we can say, okay, the opposite over the adjacent is going to be theta here, where the opposite is the distance between the two stars, and the adjacent here is going to be the distance from the telescope or the aperture and the stars. So let's now solve the question. Okay, so what we can do here, okay, I'm going just to copy this here. So basically these are the two stars here talking about. Now the distance here between the two stars are 4 times 10 to the power of 16. If you like, I can split this angle here into like into two halves, right? So I can say, okay, so I can say the half of the angle, and then so I can see clearly the right angle triangle. I mean, it will not make big difference, but just for you to be more convinced. Okay, so let's say, okay, we have here right angle triangle, right? And we have now this will be half of the angle of separation. So now if the angle is 2, so this small angle here is going to be 1 times 10 to the power of 10 to the power of -7. So we can say theta, or basically tan theta, is equal to 1 times 10 to the power of -7, and that is equal to the opposite over adjacent. So now the opposite here in this triangle is going to be half the distance between the two stars. Now the distance is 4 times 10 to the power of 16, so basically you can say 2, take half of that, 2 times 10 to the power of 16, right, divided by d, which is what we need, right? Which is what we are looking for. Okay, so we can just do cross multiplication here. So d times this number here equal 1 times 2 times 10 to the power of 16, which means d has to be 2 times 10 to the power of 16 over 1 times 10 to the power of -7. Now you can bring 10 to the power of -7 up with positive power. So you will end up with 2 times 10 to the power of 16 times 10 to the power of 7. Now you have the same base multiplication, you add the power. So it's going to be 2 times 10 to the power of 16 plus 7, which is 23. Okay, everything here in SI system in meters, right? We used the approximation of a small angle where theta is equal to tan theta, and also theta equal to sine theta, which is the very small angle approximation. So the answer here is C, and that's it. Okay, so thanks for watching. Please feel free to leave a comment, any questions. If you have any specific question in the past papers, you can leave it in the comments. I will make a video for you to solve it together. And have a nice day.